And this presentation will be given by Tymon Zieliński from Institute of Oceanology of Polish Academy of Sciences. And Tymon has been working with the Institute of Oceanology for many years and receiving his scientific degrees from this institution. And he's got a position of associate professor and the director of the PhD program in at the institute, and published numerous research papers. And he has been involved in different projects addressing research and educational tools on climate change and marine environment. And now he will talk about citizen science tools and the use of citizen science, as I said already, in the research work.
All right. So I was asked to give you a short overview of my idea about the citizen science, the concept, and examples of good practices. So this is my personal view over that. I'd like to start with this gentleman, Aristotle, who was a fantastic researcher many years ago. As you can see, one of his fundamental works, Meteorology, was produced in 334 before Christ. And if you have a short overview of what's written here, it's basically a great description of the hydrological cycle. His methodology and many other discoveries were present with us and are present with us. So we're talking about almost 2,500 years of Aristotle being with us. But he's a fantastic example of one person team. Of course, he had helpers and so forth, but as a matter of fact, it was a one-person work. And for many decades, or rather 2 millennia, this is how it worked. And on the level, with all due respect to his work, but on the level of the description of natural phenomena, that was doable. Now we live in the world that we are trying to put to simplify the description, we're trying to put concrete numbers on the discoveries. And therefore, many of you, I'm sure, know the IPCC reports. These are 2 consecutive reports. And these reports are examples of collaborative work. So in each case, there are over a couple thousand researchers who use similar tools, similar level of methods from different types of science and research who collaborate, and then they contribute to this description. So in a previous slide, you saw a very nice and real description of the hydrological cycle, but now we live in the era where we need numbers. We need all these uncertainties to narrow down to 0 so that we can properly describe our environment. In this case, we're talking about climate change. Climate change, a field that is so interdisciplinary that without collaboration of hundreds, or rather, as I said before, thousands of people, researchers, it is impossible to even try to describe the whole phenomenon in the way we would wish to have, so that we can protect our planet for the future. In both cases, of course, the key issue is the knowledge. In Aristotelian times, Plato was before Aristotle, knowledge is a true justified conviction. That's the definition. And in modern times, this is New Encyclopedia. Knowledge is a set of justified information about reality with a possibility, with skills to use them. So we have a little bit different description, because we add the word skills and the expression to use them. However, it doesn't really matter. If we talk about knowledge, in both cases, the ancient science and the modern science, knowledge can be described as a derivative, or rather a function of these 3 elements: the information, context, and experience. Actually, it was Aristotle who said to experience is to learn. So if we keep using this, and there's no reason why we shouldn't be using it, we are actually in line with what he said before, except that we have completely different approach now. In both times we collect information. However, now we are able to collect far more information, pieces of information, and far better level of data we have collected recently, and we keep collecting now. But again, context and experience are the key elements to properly describe what we see. And a simple example is that if we measure air temperature of, let's say, 5 degrees in July or in August in Greece, this is information, but without a context that in summer it should be about 30 degrees rather than 5, and without our experience that several years in a row or over, I don't know, 50 years, the temperature was never 5 degrees, it was usually about 30 degrees, knowledge is not created. Only information, that's not enough. But experience is something that everyone has, because we live a certain number of years and we gain experience over the period of our lives, right? So this is our modern challenge. Climate change is just one element of the task that humanity set for themselves. We have 16 very different goals. However, all of them are completely related on each other. If you look at it, climate action basically has interrelation with any of them, because the change of climate will affect every single element we have here. If we have low education, low quality education, then many of these things will not be tackled properly, because people will have not proper knowledge and will not be able to develop proper tools to tackle these problems, and so forth and so forth. So having this interdisciplinary array of problems to solve and to tackle, we need an army of researchers. Of course, it's not that easy to find very well educated researchers in such numbers. Therefore, the concept of citizen science seems to be a very good solution for today's world of science. It's been a while now that citizen science is with us, and a short and simple definition is that it's the practice of public participation and collaboration in scientific research to increase scientific knowledge. Of course, we have the keyword knowledge here. Through citizen science, people share and contribute to data monitoring and collection programs. So as you can see down in this slide, we already have the citizenscience.org, but also all big players in promoting science, like National Geographic and the other here, are fully involved in promotion of this idea. The idea is that people get a proper training and are able to collect data in numbers that are impossible to be collected by just scientists, due to lack of time and due to the fact that if we talk about environmental studies, we need a very large regional collection of data, which takes time, which takes manpower. And therefore, it's a very good tool, citizen science, to increase the aerial collection of data. But of course, this is only one benefit of citizen science. The other benefit of citizen science is that we, through involving society, we get people who are better educated about certain types of problems, who are actually better prepared to tackle their daily environmental problems, make better decisions, simply better understand the environment. And one of the examples, as it was said, I come from Institute of Oceanology, so for me, the natural territory is ocean, and in this case, it would be ocean literacy. And through citizen participation of people in the citizen science on the ocean-related issues, we get an ocean-literate person. And if you look at this, such person understands the essential principles and fundamental concepts that are related to the ocean, can communicate about the ocean in a meaningful way, which is a very important issue these days because we have so many different types of sources of information about environment, about climate change, about ocean, that this person, through participating in certain types of research, does understand what's going on and is able to properly communicate this information, and is able to make informed and responsible decisions regarding the ocean and its resources. So we get the person who understands, as you can see in this nice picture, it's an official definition of ocean literacy. We get a person who understands the influence, how the ocean influences us and how we influence the ocean. I mean, basically, this is exactly what we need from the person who is involved in whatever way with the ocean, right? And quick examples of what citizen science projects we are involved in. It's the project Smartfin that was started by an American company that builds surfing fins for the surfers, and they decided to install a small, not an instrument, but a sensor for collecting surface temperature data. And as you can see, the project just spread around the world, including the Baltic. I'll show you our own chapter, the Baltic, the Sea Baltic, and you get this information online from different parts of the world in the coastal zone with properly described an analysis of the data. We're at the beginning of the trip, so it's a simple measurement of surface temperature in the coastal zone. But it is only one parameter, but for the satellite measurements, it's an important parameter because satellites have a big problem in the coastal areas because the algorithms which are used for the analysis of the satellite data go a little bit crazy in the area where the sea meets the land, which means that algorithms usually are either cut for the sea or for the green surface. So in this area, there are lots of discrepancies in the data. So this is one example how citizen science can contribute to produce proper data that is actually valuable for the, let's say, real science society. Through this project, we get people involved, as you can see, all over the world, including the Baltic. I'm sorry, it's I can't see it very well because okay, that doesn't matter. Including the Baltic, which was a huge surprise for our American colleagues that there is surfing going on in the Baltic, in November, January, and so forth. There's a bunch of, I would say, from my perspective, crazy people. From other perspective, would be great guys who actually challenge the Baltic Sea in really very tough conditions. So on this small level, we started the project together. We provided them with basic the instrument or the sensor. We provided them with basic knowledge, what we would expect from them and so forth. And they give us back real data. we are working on a certain number of workshops that we are supposed to have in spring, but due to the COVID-19, we must have canceled them. But that would be our next step. And by this, we involve a group of people from all over Poland, because strangely enough, mostly surfers in Poland come from the south of Poland, which means far away from the sea. But at the same time, in the local communities where they do surf, we plan to have meetings with the local communities and discuss these issues. So we are building this community that will be ocean literate. That's what we hope for, through the citizen science project. And this is a good example of how citizen science can be meaningful in the world of science that is very, very much invested with lots of money and is on very high level. Yet, if we talk about data from long-term data from different parts of the world, such example provides a great deal of confidence that citizen science makes sense. And I know from my colleagues who work with the satellites on the Baltic that these data will be incorporated in their algorithms in the near future. So yes, citizen science is a good tool, and I certainly believe we should go in this direction. Of course, properly prepared and properly managed. So with this, I will thank all these contributors, and if you have any questions, I'll be happy to try to answer them.
Very much thanks to you delivering this another perspective, and especially it was really interesting to hear it from a real scientist that citizen science may work these times and may provide a lot of valuable inputs to real monitoring and collecting more scientific and research data. So
definitely.
Thanks a lot.